Okay, we're going to move into something called regression analysis, correlation and regression. Let's say we have the following data. We have the weekly number of hours a student studies outside of class, and we have GPA. And let's say that we've done a study of a large number of students, and we find that GPAs tend to be very closely correlated with the hours of study. I had some errors here, and I forgot to white them out. These columns don't line up as nicely as we would hope. But as long as you're aware of that, it shouldn't cause any great difficulty. We see that somebody who doesn't study at all generally gets an 0.4 GPA. There are some classes you can pass without studying, but most classes you're going to fail. And even if you pass without studying, it's going to be a low pass. Somebody that studies 5 hours tends to make about a 0.9, and again, this would be an average over large numbers of individuals that report studying these different hours. Okay, and for 10 hours, the average seems to be 1.7, for 15 hours 2.3, and so forth. So we can see, as expected, that the GPA goes up with the number of hours studied. We could depict that graphically if we simply drew a graph of GPA versus hours studied. And this isn't a particularly accurate graph, but it'll do for the present. Now, if I want to make... Okay, you see these points seem to lie pretty close to being on a straight line, but it's not perfect. If you put a straight line here, you can see there's a little curvature. So there are various ways that we could position this straight line. The way that we're going to take as the best possible position is the one where the mathematical definition of this thing, I'm not doing a very good job here, let me start over. Mathematical definition of the best fit line that we use in statistics is the line that minimizes the total squared distance, or the total more or less a standard deviation of the points from the line. So we take the average squared distance of the point above or below the line, and that's what we want to minimize. Now that requires a lot of calculus, but the calculus actually gives us a formula that we're going to look at. So we don't have to know the calculus, we don't have to know how to make this happen, but we will use the formula to calculate the slope and vertical intercept of the line that best fits a data set. And we'll also look at how reliable that line is by something called the correlation coefficient. So again, we can take data that we expect to be correlated, like hours of study and GPA, we can graph it, and then we can get a line that fits that data and use that line to make various approximations and answer various questions.